Hi everyone, welcome to MathWorld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 5 Probability and Statistics 1 for October-November 2022, and the code is 9709/52. Alright, so let's move on to question 1. Okay, question 1. On any day, Kino travels to school by bus, by car, or on foot, with probabilities 0.2, 0.1, and 0.7 respectively. Okay, now the probability that he is late when he travels by bus is x. The probability that he is late when he travels by car is 2x, and the probability that he is late when he travels on foot is 0.25. Now, the probability that on a randomly chosen day, Kino is late is 0.235. That means this is the general probability. Right, now A, find the value of x. Okay, so for this case, I will draw a tree diagram. Okay, so to get a better picture. So it means that generally there are 3 ways to travel. Okay, so this is bus, B for bus, and then C for car, and F for foot. So the probability that he will travel by bus is 0.2. Alright, then by car is 0.1, and on foot is 0.7. So now, but then from each of this way to travel, right, he will be late by bus is x. So here is late x, and we only have 2 cases, either late or not late. Then the probability that he is late when he travels by car is 2x. So here is 2x. This is late, and then here is not late. And then the probability that he will be late for traveling on foot is 0.25. So here is late, 0.25, and not late. So I know that not late is going to be 0.75. Alright, so from here, it's given that the probability that he will be late is 0.235. So I would say that PL equals to 0.235. Alright, so 0.235, when you refer to this tree diagram, basically he will be late by bus, by car, or on foot. So we have 3 methods for the traveling. Right, so for the first one, it will be 0.2 times x. This is by bus and late. Or is plus, by car is 0.1, and then the probability of being late is 2x. Or on foot is 0.7, and the probability will be 0.25 for being late. Alright, so from here, when you simplify, this is going to be 0.2x plus 0.2x plus 0.175. So equals to 0.235. So I know that 0.4x will be 0.06. Therefore, we can find that the x is basically 0.06 divided by 0.4, which is 0.15. Okay, so this is a probability, this is a value of the x. That's all for the A. Okay, now B. Find the probability that on a randomly chosen day, Kino travels to school by car. Given that, okay, this is a keyword, given that he is not late. So whenever you see given that means this is a conditional probability, which means I will write P is probability, by car, travels by car. So C, given that is a slash, he is not late. So L bar. Okay, so from the conditional probability, it will be P C intersect L bar over P L bar. Alright, the L bar means it is not late. So now, C and not late. So let's move on. Let's refer back to the tree diagram in the previous part. So C and not late means that, okay, now from here, we have found the x value. The x value is 0.15, which means this is 0.15. Okay, so now my not late, the probability of not late by bus is 1 minus 0.15, which is 0.85. So now I can complete my tree diagram. Then for this 2x, it becomes 0.3. Because 0.15 times 2, it will be 0.3. Then the other one is 0.7. Okay, so from here, I know that the probability of C intersects not L, the L bar, is basically this multiplication. So 0.1 times 0.7. So from here, I will get 0.1 times 0.7 over not L. So now you have to consider all the not L. Alright, so if not L, then I will have B and not L, or C and not L, or F and not L. So my multiplication becomes 0.2 times 0.85 plus 0.1 times 0.7 plus 0.7 times 0.75. Okay, so here I will write that is 0.2 times 0.85 plus 0.1 times 0.7 plus 0.7 times 0.75. Okay, so I get it from the tree diagram. So now, when you simplify, it will be 0.0915. So that's all for the working of B. Okay, so now let's move on to question 2. The lengths of the rods produced by a company are normally distributed with mean 55.6 millimeters and standard deviation 1.2 millimeters. In a sample of 400 of these rods, how many would you expect to have length less than 54.8 millimeters? Alright, so before you count how many of them to have this length, which is less than 54.8, I need to calculate the probability of the length, which is less than this value first. Alright, before I get this number of the rods. So now I will say that X is normally distributed, mean is 55.6, standard deviation is 1.2. So in the distribution, we need to write 1.2 squared to represent the variance. So now first of all, we need to count probability that X is less than 54.8. So now since your X is normally distributed, then we need to standardize it. So when we standardize, rewrite the X value minus the mean 55.6, then over the standard deviation. So now the standard deviation is 1.2. So when you count the value, that will be negative 0.667. Okay, so now I will draw the graph. The middle is 0. Now the value is negative 0.667. It will be on the left hand side. Okay, and since this is less than, that means the region will be towards the left hand side as well. But then when you refer to the normal table, right, so you will be given the Z value, which is on the right hand side. It should be positive. That's why I need to flip, or I need to reflect. So once I reflect this line, this region, to be the positive, that means now my region is a green color. But then you must understand that the original region is the blue color. So now in order to get the green color, right, and when you refer to the table, the graph is always the region towards left hand side. So which means I need to use 1, which is the total area, minus PZ less than this 0.667. It will be the green region. And green region is basically symmetrical to the blue region. Okay, that is the probability that we need to count. So from the graph here, I get the idea that this Z probability that Z less than negative 0.667 is basically same as 1 minus PZ less than 0.667. Okay, so now you read the value from the table, 0.667, it will be 0.7477 from the table. Then now your probability is 0.2523. Okay, And then the question asking for how many of you expect out of 400 to have this length. So now this 0.2523 is basically for one road. So for one road, it will be 0.2523 probability to have the length less than 54.8. So now I would say that expected number of roads, right, it will be 400 multiplied by 0.2523. So from here you will get 100.92. Then from here I could estimate it will be 101 roads. Alright, so this is how we solve this 2a. Okay, now part B. Find the probability that a randomly chosen road produced by this company has a length that is within half a standard deviation of the mean. Okay, so within half a standard deviation of the mean means, let's say I draw a number line to show that this is a mu, mean is a mu. Within half a standard deviation means that here is half of standard deviation, and this length is also half of standard deviation. Okay, so which means my value for these two brackets, for these brackets will be mu plus half sigma, and this is going to be mu minus half sigma. Okay, so it means that you need to count what is the probability of this. Alright, so I will say Px between mu minus half sigma and mu plus half sigma. This is what you need to count now. So I do not replace the mu and sigma value because I will just direct standardize it, right? So for information, when you standardize it, normally we will just write the x value, these two are the x values, minus the mean. So x value minus the mean is our mu over sigma. That is how we standardize it. And then the middle value will be z. Then here, mu plus half sigma minus mu over sigma. Okay, so from here, when you simplify, right, so mu minus mu will be 0, minus half sigma over sigma is basically just minus half. And then same for the last term, it will be just positive half. Okay, so now the half is basically 0.5. So now I can just draw the graph. Okay, my graph should be symmetrical. Right, so now my z value from minus half to half. So let's say here is 0.5, and then here is positive 0.5 and negative 0.5. So now my region is in the middle. Okay, this is a probability that you need to count. But then remember, the table never show negative. So I will flip this part to be here, to be right side. That means the total region is double of the green color. Okay, so I will write this is same as double of green color. So the green color is actually the region from 0 to 0.5. So I will write bounded by 0 and 0.5. And now to count this probability, the green region, I will say it is Pz less than 0.5 minus Pz less than 0. Okay, so now when you read the table, Pz less than 0.5 is basically 0.6915. Then Pz less than 0 is 0.5. So when you calculate this value, right, it will be 0.383. So this is how I solve this question. Okay, now question 3. 3 fair 6-sided dice, each with faces marked 1 until 6, are thrown at the same time repeatedly. The score on each throw is the sum of the numbers on the uppermost faces. Right, you are throwing 3 fair dice. Now, Find the probability that a score of 17 or more is first obtained on the 6th row. Alright, so I need to count what is the probability of getting at least 17 scores. Okay, the sum is at least 17. So it means that now, if let's say sum is 17, let's say my x is sum of 17 or more. Right, so now I will list down my outcomes. So to get 17 or more means minimum is 17. It will be probably 5, 6, 6. This is 17. Or my 5 is in the second place, so 6, 5, 6. Or my 5 is in the third place, 6, 6, 5. All this will be giving you score of 17. The total is 17. But it's measured or more means that it could be 18. So 18 happens when all show 6. Alright, so these are the 4 outcomes for score of 17 or more. So now, the probability of getting x, right? So from here, I will say that it is, now you see, they are fair dice, okay? These 3 are fair dice, means that each phase will have the same probability, which is 1 over 6. So to get number 5 is 1 over 6. To get 6 is 1 over 6. To get another 6 is also 1 over 6. So it means that it happens to all these 4 outcomes. So since they are having the same probability, I can just direct times 4. Alright, so you can write in this form, or you can write 1 over 6 power 3, then times 4 is up to you. Then you will simplify it to 1 over 54. Means that this is the probability of success, right, to get score of 17 or more. Now, when you refer back to this question, you need to get score of 17 or more is the first obtained on the 6th row. That means this is a geometric distribution, right? So I will draw 6 lines. 1, 2, 3, 4, 5, 6. But this is the first success, okay? First success. My success is to get score of 17 or more. That means all the previous 5 will be failures. So 5 failures. Right? So now I will say that my P is a probability of success. That is 1 over 54. Then my Q is a probability of failures. It will be 1 minus 1 over 54. You will get 53 over 54. And based on this diagram, alright, or based on this, this diagram, I will say that there will be 5 failures. Okay, all first 4, 5 are failures, means the probability. Okay, so here you can write probability equals to failures is 553 over 54, because each row is independent, right? So I will say that each row is independent, right? So therefore degree 5, because each one is same probability, each one having same probability. So you multiply 5 times. So multiply the value 5 times. So then first success means that it will be 1 over 54. Alright, so from here, at last you will get 0.0169. So that is the probability for this case. Okay, so now B, find the probability that a score of 17 or more is the same probability. That means our P is 1 over 54, which is my success in the part A, is obtained is in fewer than 8 throws. Alright, so since we know that this is geometric, okay, so I will say that there are 2 methods to solve this question. So now, the easiest method is P y less than 8, or I will say, alright, I will write y less than 8, because less than 8 throws. I will not use the x because my x is a score, right? So now my y is referring to the number of throws. So py less than 8, it will be 1 minus q to the power of 8 minus 1. So that is the formula for geometric, right? So it will be 1 minus my q will be 53 over 54 from the first part. So here 53 over 54 to the power of 7. Then you will get 0.123. So this is the shortest way to solve this question. Or if you cannot recall this formula, right, most likely you may use step-by-step working. So py less than 8, it will be py equals to 1, because you cannot write y equals to 0. So you must have thrown at least one time to get the score of 17 or more. So py equals to 1, or py equals to 2, or py equals to 3, or py equals to 4, or py equals to 5, or py equals to 6, plus py equals to 7. Alright, so when py equals to 1 means that when you throw the first time, you already obtained score of 17 or more. Means that it is the success. Alright, so this is the longer way to solve. But when py equals to 2 means that you get this score at the second throw. Means that the first throw is failure. Alright, so 53 over 54, then 1 over 54 degree 1. Plus y equals to 3 means that first two throws are failures. So 53 over 54 degree 2. Then 1 over 54, because the last throw, the third throw, is a success. So same for the next one. Py equals to 4 means that first 3 throws are failures. Then followed by 1 success. So when py equals to 5 means first 4 throws are failures. The last one is a success. Plus px equals to 6. First 5 throws are failures. And then followed by the last is success. Okay. Or the last, y equals to 7 means first 6 throws are failures. Then last one is success. So when you use this method, you will be getting the same answer, 0.123. Okay, so we have two options to solve this question. Right? Okay, now question 4. The time taken in minutes to complete a word processing task by 250 employees at a particular company are summarized in the table. So you are given the time taken in minutes and the frequency. So draw a histogram to represent this information. Now, we know that histogram either frequency or frequency density in the vertical axis, and the horizontal axis is always the boundaries, the class boundaries. So now let's check the class width. So the first class, the width is 20. 20 minus 0 is 20. Okay, because the boundary here is 20. Then here is also 20. The next one is 10. Alright, so here is 10. Then this is going to be 40. These are the class width. So because of different class width, so we need to use frequency density. So frequency density we need to calculate first. Therefore, I'm going to copy this table. Time taken is T. Then this is a frequency, F. Alright. Then now I need to get class width. Let's say C. Then frequency density. So frequency density, let's say FD, it is counted by F over C, frequency over class width. So when 0 to 20, right, 32, class width is 20 because the upper boundary is 20, lower boundary is 0. Then now, the next one, here is 46, then here 20, then 40 to 50. Basically, I'm rewriting. I'm copying the table. Then the width here is 50. Here is 50 minus 40. That's why I get 10. Then two more classes. So here is 52. The width is 10. from 60 to 100. Here is 40. So now frequency density is F over C. So this is our F over 20. 32 over 20. I will get 1.6. Then the other one is 2.3, 9.6, 5.2, and 0.6. Okay, so now I am using frequency density as the vertical axis, and the horizontal axis will be the boundaries. So for here, boundary will be the same as the classes. Alright, so now let's check. The frequency density, highest is 9.6, lowest is 0.6. Okay, then the classes will be from 0 to 100. So now this is the graph. Okay, so I will just draw here. Let's say here is 100. Sorry, the frequency density 10. 9.6 I will label as 10. Then here will be 8. This is 4. Here is 2. And this is 0. Okay, then this is my horizontal axis. So please draw using ruler. Then I will label this as frequency density. Right. So now my horizontal axis is going to be the time taken. So 0 to 100. So it means that here is 0. Let's say here is 20. This is 40, 60, 80, 100. This is time taken in minutes. Right? So here, so firstly, 0 to 20, the height is 1.6. So 1.6, here is 1, which means each small square will be 0.2. So 1.6 is going to be here. Okay, next, 20 to 40, which is here, 20 to 40, the height is 2.3. So 2.3, 2.2, 2.4. So roughly here, in the middle. Okay, so please draw using ruler. Then the next is 40 to 50. The height is 9.6. So 9.6, 40 to 50. Okay, so please hang on. Right, so 9.6. Here is 9. Here 2, 4, 6. That means it's this height. Okay, then when 50 to 60, it is 5.2. So 50 to 60, 5.2. Here is 5. Then 0.2 is over here. Oh, sorry, I marked wrongly. This is 6. Okay, here is 6. This is 8. Okay, I labeled wrongly. This is 10. So here is going to be frequency density. Right, so 9.6 means that I need to extend my histogram. So here is 9, 6 is over here. Right, then the other one is 5.2. So 5.2, this is the height. Okay, lastly, 60 to 100 is 0.6. So 0.6246, which means it's this line. Okay, so this is the histogram. Right? Okay, so from the data, the estimate of the mean time taken by this 225, by these 250 employees is 43.2 minutes. Calculate an estimate for the standard deviation of the times. Alright, so standard deviation is basically square root of summation fm square over summation f minus the mean squared. Right, this is the formula. So now the m here means the midpoints. Means now we need to calculate the midpoints. So how do we count the midpoints? Is basically summation of these two values and then divide by 2. Okay, so I will list down the midpoints right now. So I will write here. Okay, here is going to be midpoints. M. Right, I will just write M here. M. This will be the F. So when the F is 32, okay, let's copy back here. I will copy down all the F first. 32, 46, 96, 52, and 24. So 46, 96, 52, and 24. Okay, now how to count the M, the midpoints? So if I mentioned just now, 0 plus 20 divided by 2. So I get 10. Right? 20 plus 40 divided by 2, I will get 30. So same goes to others. Therefore, I will get 10, 30, 45, 55, and 80. Okay, so now the summation fm squared, you can direct replace. So it will be square root. So summation fm squared means that you square the m and multiply by the f. So I will get 32 fm squared. The first fm squared is 32 times 10 squared. Then the next is 46 times 30 squared plus 96 times 45 squared plus 52 times 55 squared plus 24 times 80 squared. That will be my summation fm squared. Then divided by the total f here is the total employees, which is 250. So divide by 250 minus the mean squared is given 43.2. Okay, so when you count the values or the sum, then I will get 54990. Sorry, 549900 over 250 minus 43.2 squared. Right, so now you will get the answer in the next step. So the answer is 18.3. Okay, so that's all for this question. Question 5. Eric has 3 coins. one of the coins is fair. The other two coins are biased, so that the probability of obtaining a head on any throw is 1/4. And independently of all other throws, means that each throw will be independent. Eric throws all three coins at the same time. Events A and B are defined as follows. A means all three coins show the same result. B, at least one of the biased coins shows a head. Now A shows that PB is 7/16. So now you need to focus on the biased coins, right? So now what I need to do here is I will write down the 1/4 is PH bias. The B means bias, alright? So it will be 1/4, which means PT bias. So the bias coin show you T, the tail, will be 3/4 because a coin only has two faces. Now, for the PB, so I need to start solving. This PB is to show that at least one of the biased coins shows a head, which means, right, so when you consider the results, right, you will get how many heads, right? So it could be, say, you will say that it could be at least one of the bias, means that it could be one bias coin shows head or two bias coin shows head. So now when our concern is the bias coins, when you observe the two coins, okay, so the results will be maybe 0 bias coins shows head, maybe 1 bias coin show head, maybe 2 bias coins show head. Alright, so from here, because at least 1 means that instead of calculating 1 and 2, I can use the complementation rule, which means 1 minus probability that none of the bias coin shows head. None of bias coin shows head. Because it can be none of them show tail. Both of them show tail, means that none of them show heads. Alright, so this is same as both of them show tail. So both bias coins show tail. Right? So if you want to see clearly, so you can write 1 minus, right? So here will be tail for B. The first one is bias, tail, right? The second bias coin show tail, and then the fair coin show tail, or first bias coin show tail, because we need to count the probability that both bias coins show tail. So second bias coin, this is second, this is first, show tail as well, but then the fair coin show head, right? So now 1 minus PTB1, because they are independent, it's mentioned here, they're independent, right? So I can just multiply. So PTB1, so PDB is 3/4, means that first bias coin show tail is 3/4. The second bias coin show tail is also the same probability. So you can just multiply. And then the fair coin, okay, PTF is half, because it's fair. PHF, fair, the F means fair, is also half. So then this is half. Okay, all is plus. Then the first one is 3/4, the second 3/4, and then the PHF is 1/2. Right? So then when you calculate, it will be 1 minus 9/16. Then at last you get 7/16. So you may use this method to solve, or another method is, right, you can just say that it is PB equals to 1 minus P both bias coins show tail. So when both bias coins show tail means that we will focus on the bias coin. We don't bother the fair coin anymore. Means that 1 minus the first bias coin show tail 3/4. Second bias coin show tail also 3/4. So here you will get 1 minus 9/16, and you will be getting the same answer as well. Okay, so you can just ignore the fair coin because our concern is the bias coin. So this is another option to show this question. Okay, now part B. Find a probability A slash B. So this is conditional probability. So P A slash B, it will be P A intersect B over PB. So we have counted the PB in the previous part, which is 7/16. But then what is your A intersects B? Alright, so now let's look at the A first. What is the A? So now A means all three coins show the same result, means that all tail or all head. But then the B is at least one of the bias coins shows a head. So when you consider the intersection between these two events, is basically either all head or all tail. So here can be one head from the bias coin or two heads from the bias coins. Then the fair coin can be head or tail. So the intersection of this is basically triple H. Okay, because you must have at least H there in the B. So that means my A intersect B is basically all H. Right? So when all H, it will be here B, here B, here T, or F. Right? So both bias coins show head and the fair coin also show head. So now the probability of bias coin show head is basically 1/4. So here I will write 1/4 power 2, or you can just write 1/4 times 1/4. Then the fair coin show head is half. Then over PB, you get it from the previous part, 7/16. So when you divide this, you will get 1/14. That is the probability of A slash B. Okay, so now the random variable X is the number of heads obtained when Eric throws 3 coins. C, draw up the probability distribution table for X. So since he throws 3 coins, so you may get X equals to 0. X equals to 0 means no head. No head means all tails. So TB1, TB2, and then TF. Alright, so the probability of X equals to 0, so I will rewrite my PTB equals to 3/4 PHB. So it means that the bias coin shows the H is 1/4. And then PTF. Okay, the fair coin show tail is same as fair coin show head. It is half. Alright, so now the bias coin show tail means that it is 3/4 power 2, because each one will be the same result, multiplied by half. So then you will get 9/32. So when X equals to 1 means that 1 head. So X equals to 1, I may get head from the bias coin, then tail for the other 2 coins. Okay, it could be tail from the first bias coin, head from the second bias coin, tail for the fair coin, or it could be both bias coins show you tail, and then the fair coin show head. So for this case, Px equals to 1. Now the first one is 1 over 4. TB is 3 over 4. TF is half. Now you will notice that the first probability and second probability will be the same. So TB1 is 3 over 4. Second is 1 over 4. And then TF is half. Or TB1 is 3 over 4. 3B2 is also 3 over 4, so you can square it. Then HF will be half. So when you count this value, it will be 15 over 32. Now we know that Eric is throwing 3 coins. So the number of heads can be 0, 1, 2, 3. So you can count Px equals to 2. Or I can just count Px equals to 3 directly. So when Px equals to 3 means that all 3 head. So I will get H from bias coin 1, H from bias coin 2, H from the fair coin. Alright, so now my Px equals to 3, it will be 1 over 4 times 1 over 4 means squared, then times another half. So at last it will be 1 over 32. Okay, so now from here, if you are confident that your probabilities are accurate, so I can direct draw the probability distribution table for the x. So I will write down my x values 0, 1, 2, and 3. Then the corresponding probabilities. So when x goes to 0, it is 9 over 32. When it is 1, 15 over 32. When it is 3, 1 over 32. Then what happened to x equals to 2? So when Px equals to 2 is basically 1 minus the rest. Alright, so I will write it here. So it's supposed to be 1 minus these 3 values. Because the total probabilities must be 1. Then you will get 7 over 32. So this is the table. Right, this is the probability distribution. Probability distribution table for x. Right, so this is the solution for whole question. Okay, now question 6. At a company's call center, 90% of callers are connected immediately to a representative. A random sample of 12 callers is chosen. So since the callers are discrete random variables, that means this is binomial. Okay, binomial distribution. So A, find the probability that fewer than 10 of these callers are connected immediately. So now I will write x is binomial. The n is 12. 90% are connected immediately. So it means that it is 0.9. That is the success rate. So now fewer than 10. So Px less than 10. So for this Px less than 10, supposedly from 0 until 9. But then you have to calculate 10 values. 10 probabilities is a lot. Therefore, I will use the complementation rule, which is 1 minus Px greater equals to 10. Alright, so I will have less calculation. So this is basically Px equals to 10, 10 onwards, but up to 12. So I just need to count Px equals to 10, Px equals to 11, and also Px equals to 12. Okay, then the binomial distribution formula is Px and B and P. So Px equals to x, it will be NCx Px Qn minus x. So I'm going to apply this formula. So it will be 1 minus My n is 12, so 12 C10. My probability of success is 0.9, which is my p, power 10, 10 successes, 0.1 failure, and there are 2 of them because we are considering 12. 12 out of 12, 10 successes means that 2 failures. Then 12C11, 0.9 degree 11, 0.1 degree 1, plus PS equals to 12 means all successes, so 0.9 degree 12. Alright, so when you use this value, use this method to count, 1 minus the total of these 3 probabilities will be 0.8891. Then you will get 0.1109 and round up to 3 significant figures. That will be 0.111. Alright, so I have solved A. Now let's move on to the next part. So a random sample of 80 callers is chosen. Now find or use an approximation to find the probability that more than 69 of these callers are connected immediately. So just now was small sample, okay? So now becomes 80. So means that X is binomial, 80, and the probability remains the same, 0.9, 90%. So now your n is larger than 50, alright? That means you have to count what is your NP. So 80 times 0.9, it is 72. Since this is greater than 5, alright, so we need to apply normal approximation. So normal approximation, the variance is NPQ. So NPQ, since the NP already counted, which is 72, so I will write 72. My P is 0.9, therefore my Q is going to be 0.1. So here I get 7.2. Alright, so now I will write my X is binomial, 80, 0.9. It will be approximate to W with normally distributed. Okay, and then the mean is 72, variance is 7.2. Okay, now you need to count the probability that more than 69. So it means that Px more than 69. So you must take note on this. Your B binomial distribution is discrete. It's for discrete random variable. But the normal distribution is for continuous random variable. So when you approximate discrete to normal or discrete to continuous random variable, it's compulsory to consider the continuity correction. Alright, so now I will draw the number line to decide what is the continuity correction. Either you plus 0.5 or minus 0.5. So since x more than 69, so I will label 69 first. But then my actual x starts 70 because it's more than 69. So it will be 70 onwards. This will be my x values. And now we are allowed to plus minus 0.5 from the given x. So when I minus 0.5 from 69, I will get 68.5. If I plus 0.5 from 69, it will be 69.5. Okay, and now when I solve this probability Px more than 69, I need to rewrite. So I'm sure that my x will be converted to W because this is the approximation, but then the more than remains the same. Alright, so now you have two choices. Either you choose more than 68.5 or more than 69.5. So obviously we are choosing 69.5 because when you choose more than 69.5, then the next value is going to be 70. Alright, so 69.5. So now once you have converted to this W form, that means now you are solving the probability for normal random variable. So now we need to standardize it. So when you standardize, you minus 72 over 7 over 7.2 over the standard deviation. So from here you will get Z more than negative 0.932. Okay, so now before we refer to the table, let's draw the graph. Simply sketch a graph. Middle value is 0. The line is negative, so it is on the left hand side. and then the region is more than, that means it's towards the right hand side. This is our region now. But then you must remember that the normal graph always show positive z value and the region is towards left hand side. So due to that reason, I cannot accept this negative value, but I will flip it in the line y equals to, the middle line, when the z equals to 0, because this is symmetrical. So once I flip, it will be on the right hand side. So here becomes 0.932. And now when you observe the region, we do not consider minor region, but we consider major region. And same for the reflected graph. So it will be the reflected region. Okay, so once you have refracted it, that means it is same as pz less than 0.932. Okay, and now you can read this value less than 0.932 from the normal table. So the normal table gives you 4 decimal places, 0.8243, and now you round up to 3 significant figures. So it will be 0.824. Okay, so that's all for this solution. Now, see, justify the use of your approximation in part B. So now, this is to explain why do I choose normal approximation. Okay, so the reason is very simple. The NP is greater than 5. So now, NP is 80 times 0.9, which is 72, is greater than 5. And then you need to prove the NQ as well. So NQ is 80 times 0.1. This is 8. Right, which is greater than 5 as well. So now you write approximation is used, normal approximation. Okay, due to NP greater than 5 and NQ greater than 5. So these two are the conditions for the normal approximation to binomial. Okay, so now last question, number 7. Find the number of different arrangements of the 9 letters in the word alligator in which the 2 A's are together and the 2 L's are together. Okay, so now first of all, alligator. So you will have 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there are 9 letters. Out of the 9 letters, we have 2 A's, we have 2 L, the rest just once. Okay, so now you need to arrange so that A's and 2 A's are together, 2 L's are together. So when I arrange, I will write 2A in one group, then 2L in another group, so that they will be always together. Right? And then now out of the 9, I have considered 4 letters. That means you still have 5 more letters. So now the question just says that the A's must be together and the L's must be together. So we can put it in any places. Alright, so basically you have 1, 2, 3, 4, 5, 6, 7. So when we group the A's and L, that means we treat them as 1. Alright, so it means that we are arranging all different 7 letters because all the rest are different letters. All the remaining 5 letters are different letters. So from here, I will just write number of arrangements equals to 7 factorial because you need to arrange all of them. So it will be 5040. That is the 7A. Now B, the 9 letters in the word are arranged in a random order. Again, arrangement is important. Find the probability that 2 L's are together and there are exactly 6 letters between the 2 A's. Alright, this one is very important. So let's say now I start with A. Then I will have 6 letters. 1, 2, 3, 4, 5, 6. This is my A. Okay, therefore 6 letters between 2 A's. Now, when you consider 6 letters together with the 2 A's, it's already 8 letters. So remember, alligators has 9 letters. So it means that 1 will be here. Okay, maybe the front and the back. So I will say that maybe the front, then A, 1, 2, 3, 4, 5, 6, another A here. These are the 2 possible arrangements. Okay, and don't forget the 2 L's are together. Means that now probably I take these 2 as a L, alright, and then these 2 as a L. The 2 L's can be in any places, but of course cannot be front and back because there's only one space here. Alright, we need 2 spaces. So what to do here is, firstly, alright, so again, here you have 9 letters. You have 9 letters. Now, when you look at here, since the A already fixed, the L already in one group, means that now I need to check. I need to find out how many ways to get this first. Right? I'm not going to arrange this anymore because this last place already fixed must just has 1 letter. So it means that now at first you have 9 letters minus the 2 A's minus the 2 L's means that you still have 5 more left. So which means here you have 5 choices, right? Because you have 5 more left, then you need 1 only. Therefore, here will be number of arrangements, or probably the questions here says probability, so I will just direct write probability. Okay, it will be number of arrangements. So the last one will be 5, choose 1. Okay, after that, the A's I will not change anymore, and these 2 A's are the same, so no need to consider the arrangements of these 2 A's. Now, we need to consider the letters in between the 2 A's now. So here will be 1, 2. Since the 2 L's are together, we treat this as 1. So that means this is 3, here is 4, here is 5. So we have to arrange these 5 letters in between the A. So therefore, it will be 5 factorial. Because there will be 5 different letters. Okay, now this is for the first case. But then the second case is still the same. We have to consider this, which is 5C1, and then here the middle also 5 factorial. So I can say that it is times 2 because it will be the same. 5C1 times 5 factorial. Okay, this will be the number of arrangements that satisfy this condition, these 2 conditions. Now, since we are counting probability, so you must divide by the NS. NS means the number of arrangements without restriction. So in general, you need to arrange these 9 letters. Therefore, 9 factorial. But you have 2 L's and 2 A's, right? 2 A's and 2 L's. Therefore, divide by 2 factorial and 2 factorial. That will be your NS. This is your NS. Okay, so when you simplify this, it will be 1200 over 90720. So when you count separately. So now, the final answer will be 5 over 378. So you may leave your answer in fraction or in decimal. Alright, so this is how we solve the parts B. Okay, part C. Find the number of different selections. So now arrangements is not important. From 5 letters, or 5 letters from the 9 letters. So from 9 you choose 5. Okay, so alligator. We have 2 L. We have 2 A's. Okay, there are 9. So I will say that here 2 A's, 2 L. There are 9. Alright, so you need to choose 5. Okay, so how do you choose 5? Which contains at least 1 A's and at most 1 L. So this 5, maximum or minimum 1 A's, maximum 1 L. Okay, these are the 2 conditions. So from here, since this is at least 1 A, means that I may write 1 A and then 1 L. Okay, because you must have maximum 1L. So I consider minimum 1A, maximum 1L first, which means I get A and L. So when you get A and L, don't forget we need 5 letters. So it means that I have another 3. Now remember, this is selection, means the arrangement is not important. Okay, so then now the next one is going to be probably consider 2 A's, or I will consider 1A. Okay, let me complete the L first. 1A. Just now I consider 1L, so you can consider less than 1L, means that 0L. So when 0L means that I have 1A and then the rest of the 4 letters. Then after that, I may consider 2A's. So when 2A's, right, maximum 1L, then I will get A, L, and I need another 2 from other letters. Then I may consider 2A's and 0L. So here I'll get A, then triple line. Okay, so how to select? So for the first one, the selection is going to be, now remember, we don't consider A and L anymore, which means, right, so you exclude A and L. So I need to consider the rest of the 5, I, G, T, O, R. So from these 5, I need 3 for the first case, which means it is 5C3. So number of selection, it will be 5C3 for the first, or, alright, so for the second case, I need 4 from the 5 because I need to exclude the A and L. Then for the third case, I need 2 from the 5, I, G, T, O, R. Then for the last case, I need 3, any 3 from the 5, I, G, T, O, R. So 5C3. Alright, so when you count each of these, it will be 10 plus 5 plus 10 plus 10. Therefore, the answer is going to be 35. Alright, so this is the solution for the C. Okay, so that's all for this video. Right, so thank you for watching. Remember to hit the subscribe button if you enjoy watching my video, and stay tuned for more upcoming videos. See you.